So now let us consider the first classification, which is based on sources, organic and inorganic compounds. Now, the organic compounds have been treated before when we were introducing chemistry. Under introduction to chemistry, you can go and revise or rewatch the video, but we still need to just consider it briefly over here. So, organic compounds are simply the compounds of carbon, that is, carbon compounds. So, any compound that contains carbon is likely going to be an organic compound, but there are some exceptions to the rule. So, except the oxides of carbon and carbonates and carbide. So, it means those three are not studied under organic chemistry. So, let's first consider the oxides of carbon, which are not studied under organic chemistry. Generally, carbon has two oxides. The first one is carbon 2 oxide, which is known as carbon monoxide. And the second one is carbon 4 oxide, which is also known as carbon dioxide. Carbon 2 oxide, the chemical formula for carbon 2 oxide is CO, while the chemical formula for carbon 4 oxide is CO2. So these two are known as the oxides of carbon, and they are not studied under organic chemistry. So now let's consider carbonates. Carbonates are compounds that contain the carbonate ion, that is the triazocarbonate ion, CO32 minus ion. So the triazocarbonate 4 ion is CO32 minus. So any compounds that contain the CO32 minus ion is carbonate, and it can be an acid, it can also be a salt. Example of the acid is when it begins with hydrogen. So this is H2CO3, which is triazocarbonate 4 acid. So the triazocarbonate 4 acid is an inorganic compound. So it is not studied under organic compound. But anytime a metallic ion is combined with the CO32 minus ion, it becomes a salt. That is, when we replace the hydrogen ion with a metallic ion or ammonium ion, it becomes a salt. So examples are the following. Consider these examples. This is Na2CO3, K2CO3, MgCO3, CaCO3, NH4 bracket 2CO3. All of these are metallic carbonates and they are salts. So they are not studied under organic chemistry. They are inorganic compounds. The Na2CO3 is sodium triazocarbonate 4 salt. The K2CO3 is potassium triazocarbonate 4, magnesium triazocarbonate 4, calcium triazocarbonate 4, ammonium triazocarbonate 4. So all of these are inorganic chemistry, and these are inorganic compounds, and they are not studied under organic compound. So let us consider carbide. Now, carbides are those compounds that are formed when carbon combines with either a metal or a metalloid. So it can be a metallic carbide or a semi-metallic carbide. But all in all, carbon is always the second element. So it means carbides are always binary compound. That is, compound that are made up of two elements. But carbon always comes second in the combination. So let's consider some examples of carbide. Here are some of the examples. We have calcium carbide, silicon carbide, and iron carbide. All of these, we have many more. All of these are also inorganic compounds of carbon, which are not studied under organic compound. Now, apart from the oxides of carbon and carbonates and also carbides, every other compound of carbon are organic compounds. So now let's look at examples of such compounds that are organic compounds. Consider the compound listed here. We have CH4, which is methane. We have C2H2, which is ethine. We have C2H4, which is ethene. We have C6H6, which is benzene. We have C6H12O6, which is glucose, and it's a carbohydrate. And we have CH3COOH, which is ethanoic acid. So these are a few examples of organic compounds. So let's study the classification of organic compounds. Now, consider this chart that we have here. This is a summary of everything to learn under organic compounds. Now, in a broader sense, organic compounds can be broken into two. We have the hydrocarbons and the non-hydrocarbons. Hydrocarbons are those organic compounds that contain only carbon and hydrogen. That is, they have only the carbon and hydrogen bond. No other element is attached to them. while the non-hydrocarbon contain other elements other than carbon and hydrogen. That is, including the carbon and hydrogen, we still have other elements attached to the carbon-hydrogen bond. The elements can be oxygen, it can be nitrogen, it can be sulfur, etc. Next, the hydrocarbons are further broken into two. We have the aliphatic hydrocarbons and the aromatic hydrocarbons. The aliphatic hydrocarbons are further broken into three. We have the saturated compounds and the unsaturated compounds and the alicyclic compounds. The saturated compounds are those ones that have single bond. So, and we have only one family of that, and those are the alkanes. Next, we have the unsaturated compounds. That is, compounds with double or triple bonds. The compounds with double bonds have the general family name, which is alkanes. So, and the triple bond have the general family of alkynes. So those two are unsaturated hydrocarbons. So next, the alicyclic hydrocarbons. So these ones are special. It means they both combine the property of aliphatic and also cyclic. It means they are both aliphatic and cyclic. So, and it can be saturated or unsaturated. That is, it can have single bond or double bond. An example of that are the cycloalkanes. So, next we have the cyclic compounds. The cyclic compounds are compounds that form ring shape. And the common examples are benzene, toluene, etc. So, all of these compounds will later be studied in a more broader way under organic chemistry when we get there. So now, the non-hydrocarbon can also be acidic, basic, or neutral, as the case may be. But when we get to organic compound, we'll also look deep into this. Thank you for viewing this. God bless you. Now, let's consider inorganic compounds. Inorganic compounds are compounds that do not contain carbon-hydrogen bond, the CH bond. That is, those compounds that we don't have carbon connecting or combining with hydrogen directly in them. They are inorganic compounds. So we have several examples of such compounds, and that is what we always learn in beginning of chemistry. Most of the compounds that SS1 and 2 students will meet at their level are inorganic compounds. But when they get to SS3, that's when they will talk about organic compounds. We have familiar examples like the one given above. So consider the compounds that we have on the board, on the screen. So we have H2O, which is the water molecule. Now HCl, which is hydrochloric acid. H2SO4, sulfuric acid. CO, which is carbon 2 oxide. CO2, carbon 4 oxide. HNO3, which is triazonitrate 5 acid. H2CO3, which is triazocarbonate 4 acid. Na2CO3, which is sodium triazocarbonate 4. CaC2, which is calcium carbide. All of these are inorganic compounds. You will now be wondering that what happened to H2CO3? Is it not having carbon and hydrogen? So we have explained this under organic compounds, that excluding any compound that contains carbonate. CO3 is a carbonate. Even though it is bonding with hydrogen, we cannot say it is organic or it is inorganic because CO3 2 minus are not studied under organic chemistry. And then if you look at this last example, which is CaC2, calcium carbide, which is among those carbide, and it is also inorganic. Also, CO and CO2 are oxides of carbon, and we have talked about them before. So in short, all of these and many other ones are inorganic compounds. Thank you.